All right, so this video we're going to look at integrals in exponential form. So for this one, if you can get your integral in the form of e raised to a power, then the integral of that is just e to that power. All right. So we're going to use substitution to rewrite these things. So basically, we've got to get all of our examples. I think I got 4 of them here to do. But we've got to get this to look like that. So whenever you have something like this e to a power, what you want to do is start off, let u equal the exponent. Okay? And then we have du is 2x dx. So you can see here I've got 2x dx, but here I only have x and dx. I'm missing this 2 here. So I can multiply by 2, and that gives me the 2x dx. But if I multiply by 2, I have to also come out here and multiply by 1/2. Because remember, the only thing you can multiply to something and not change it is 1. And it's, multiplying by the 2 and then multiplying by the 1/2, that's the same thing as multiplying by 1. And so now let's make our substitutions. I've got 1/2 integral. And so I've got e, and in the place of x squared, see, I'm going to put u. And in the place of 2x dx, I'm going to put du. And now you can see I have it in this form here. So my answer is just e to the u plus c. And now I have to substitute this back in for u. So that's just e to the x squared plus c. And there's my answer. All right, let's look at this one. So remember, I want it in the form e to the u du. So this one, well, I've got e to a power, but it's in the denominator. That's what's giving me some trouble here. But remember, we can rewrite this as e to the negative 3x dx. Remember, if you move something across the fraction bar, it changes the sign of the exponent. So now I'm going to let u equal my exponent. So du is just negative 3 dx. So I've got the dx, I've got the dx, I'm missing the negative 3. So multiply by negative 3, and then come out here and multiply by negative 1/3. And now the negative 3 dx, see the negative 3 dx, that can be replaced with du. So I've got e, negative 3x, that's u. And then the negative 3 dx, that's du. And so now you can see I've got it in this form. So that's negative 1/3 e to the u plus c. Make my substitution back. Plug this back in for u. Negative 1/3 e to the negative 3x plus c. Okay. Next problem. All right, so this one, well, if I just look at this real quick. If I take the derivative of e to the x plus 1, that's just e to the x plus 1. That's not even close to the numerator. Okay? So what we'll have to do is rewrite this thing to make it, to just simplify it some. So let's see what we can get. So this is the same thing. This is going to be 4e to the 3x over e to the x plus 1 minus, and what I'm going to, dx minus, I'm going to split it up into 2 integrals. That's going to be 3e to the x over e to the x plus 1 dx. So all I did is I split the fraction up, and then I broke that up into 2 separate integrals. And so this is the integral 4e to the 3x minus x plus 1. We're dividing. We have like bases, so I subtract the exponents, dx minus, and then that's going to be 3e to the x minus x plus 1 dx. And so this gives us the integral, and I'm going to go ahead and bring the 4 out. That's going to be e to the 2x minus 1 dx minus, and then I'm going to bring the 3 out. That's going to be e to the negative 1 dx. All right, so now we're wanting to integrate. So let's look at the first one. We're going to let u equal 2x minus 1. So du is 2 dx. I'm not going to mess with the second one right now. Let's just make the substitutions into the first one. So this is going to be 4 integral. Well, I've just got the dx, but I need a 2 also. So I'll multiply by 2, divide by 2. So this would actually be 4 over 2 is just 2, and that's e to the u du when I make my substitution into the first one, minus integral e to the negative 1 dx. And so this is going to be 2e to the u minus e to the negative 1 x plus c. All right, so you may be wondering, well, what in the world happened here? Well, e to the negative 1 is just a number, okay? That's the same thing as like integrating 5 dx. Well, what is that? That's 5x. Or integrating 1/2 dx. That's just 1/2 x. See, e is just a number like the 1/2 and the 5. All right, it's a constant. Oh, and I left the 3 off here, and that would be a 3 there also. And so this is 2e. Now, e to the u, so let's plug this back in for u. 2x minus 1 minus 3e to the negative 1x plus c. And yes, if you wanted to, this 3e to the negative 1x, you could write that as 3x over e if you wanted to. That's fine too. All right, so let's take a look at this last one here. All right, so let's start out. We're going to let u equal cosine 2 theta. So du is negative sine 2 theta times the derivative of what you're taking the cosine of. Derivative of 2 theta is 2, and that's times d theta. So du is negative 2 sine 2 theta. All right, so let's see, we've got sine 2 theta, d theta. I left the d theta off, didn't I? Okay, we got the sine 2 theta d theta. There's sine 2 theta d theta. I need the negative 2. So I'll multiply by negative 2. So that means I come out here and multiply by negative 1/2. So that's negative 1/2. And then let's make our substitutions. So that's e to the u. Plugging this in. See, this right here is u. And then the negative 2 sine 2 theta d theta, that's du. Now, these limits here are in terms of theta. I got to get them in terms of u. Well, what does u equal? U equals this. So, I've got u is equal to cosine of 2 times 0, which equals cosine of 0, which is 1. So I plug the 0 in. Say I plug this 0 in for theta here, and I got 1, so that limit changes to 1. And then I've got u equals cosine 2 times pi over 2, which equals cosine of pi, which is -1. And so this limit changes to -1. All right. Now, this is, you don't have to do this, but I kind of like when I'm working with these things, if I don't have to have a negative in front of my integral, a negative number, I get rid of it. In this case, and also you notice that the limit on bottom is larger than the limit on top. So we can actually rewrite this. We can switch the limits. And if you switch the limits, it changes the sign in front of the integral. So this is going to be 1/2 e to the u from -1 to 1. And so this is 1/2 times e to the first minus e to the -1. All right. And that, if you punch that into your calculator, you get 1.175. And there's your answer. All right, so I hope this video helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.